Good morning, everyone, and welcome to this lecture. In this lecture, I think we are dealing with thermodynamics. We are dealing with thermodynamic processes, and we will try to wind up the thermodynamic processes in this particular class. The last class we had seen how can we find out work done in various cases. We had seen how can we use Cp and Cv for a diatomic gas for different process. How can we find out the work done? How can we find out the heat given? So that was just a beginning of what we had done. Also, we had seen the cyclic process. In the cyclic process, the work done is the area between the cycle, and that is equal to the heat given or heat lost. We had seen a lot of questions where questions had to be solved using that diagram, and this question is going to come in any exam because from thermodynamics this is the most likely topic from where you will get a question, and I hardly seen a paper where I don't find a question based on cycles or something like that. And therefore we had done all those things together. Now in today's class what we will try to do is we will move through each and every process separately so that we understand them separately and we can analyze them separately. So basically we are going to deal with five processes, and in these five processes we would be covering everything that can come. The first of these process is known as which one? The first process that we are going to deal with is known as,
Isothermal.
yes, it's known as the isothermal process. So we will now go through this isothermal process and note out all the points. Remember, this topic that we are doing is very, very important because it is a part of your physics as well as part of your chemistry. The sign convention may be a bit different, but that doesn't matter. Whether you solve it from the physics sign convention or from the chemistry sign convention, at the end you will get the same result. So you don't have to worry. Now, we will bisect all these processes in under different headings. For the first thing, you must understand for an isothermal process, the temperature of the body remains, the temperature of the system remains constant. So that is the first thing that you should write. The temperature remains constant for this process. Now, when the temperature remains constant, PV is equal to nRT. As I told you, this process is going to take place in a closed container, so number of moles is not going to change. So the process becomes PV is equal to constant, or you can use P1 V1 is equal to P2 V2 for this process very, very conveniently. P1 V1 is equal to P2 V2. Temperature is constant, that means change in temperature becomes zero. So same thing written in different ways. Now, when this process is going to happen, sometimes they are not going to tell us straight away that this process is an isothermal process. They might be giving us the conditions of this process. Now, what do you want as conditions of this process? Under what condition can a process become isothermal? Remember, a perfectly 100% isothermal process is not possible. A perfect isothermal process is not possible. Why it is not possible? Because to keep the temperature same, there must be two conditions that must be fulfilled. What are the two conditions for a process to become perfectly isothermal? What are the two conditions that must happen? Any idea? What are the two conditions for a process to remain isothermal, perfect isothermal process? What are the two conditions? No, no idea. Okay, so the two conditions are like this. Condition number one, conditions for a process to remain perfectly isothermal. Now, if it is a perfect isothermal process, it must take place in a perfectly conducting cylinder, and the piston over here should also be perfectly conducting. Why you want it to be perfectly conducting? So that there could be a free exchange of heat between the system and the surroundings. That is the only way you can make the process perfectly isothermal. To have a perfectly isothermal, there must be a continuous heat transfer. There must be a continuous heat transfer. There must be a continuous heat transfer between the systems and the surrounding. So as soon as any heat is generated in the system, it must go out. As soon as heat is given into the system, it must get absorbed completely. So there must be a continuous heat transfer between the system and the surrounding, and that must take place in such a way that the temperature does not change. So the walls of the cylinder or the piston must be perfectly conducting. So whenever you hear this term, the process is taking place in a conducting wall, that indirectly or directly means that the process is isothermal. The second condition, apart from the conducting scenario, is that the process must be very slow. Why the process must be very slow? The process must be very slow so that there is enough time available for this heat transfer to take place. If the process takes place very fast, well, even if it is taking place in a conducting wall, there will not be enough time for heat transfer to take place, and the process will not remain isothermal. So these are the two conditions. If I say these are the three conditions, condition number one, condition number two, and all of these conditions are coming from the condition number three, that there must be a constant heat process, heat transfer taking place between the system and the surroundings. I hope you understand this. What are the examples of isothermal process? Well, the perfect example of isothermal process, we've already seen it in the previous classes. Any change of state, any change of state, wherever it is happening, wherever ice is melting or water is boiling, that is the example of almost a perfectly isothermal process, because there the temperature of the system does not change. So you can take that an example. Now, I hope everyone is noting this down. We are trying to bisect everything in terms of different headings. We will be doing everything that is possible here. All the things would be put in different points, so that if any question comes on isothermal process, you remember all those points and you can go ahead and solve this. The next thing that you must understand about the isothermal process is the indicator diagram. I hope everyone has noted this down. Yes or no? Indicator diagram. Whenever I use the word indicator diagram, it is actually a PV graph, a graph between pressure and volume. Have you noted down up till here, everyone?
1 minute, sir.
Okay. Keep noting these things down, because whatever we are writing here, either it will come in physics or it will come in maths. So you can expect maybe 3 questions even in your JEE to come from this. Maybe 2 questions in physics and 1 in maths. Same for NEET. You can have even 5 questions coming from this. 4 to 5 questions. It's very possible, because most of these are on graph based and they love graphs. They want some drawing on the paper as well. And this is the best place you can get a drawing. Noted it down?
Done, sir.
Okay. Now, if you draw this process on a graph between P and V, P into V is a constant. So the graph is hyperbolic in nature. The shape of this curve, remember, is hyperbolic. Hyperbolic. So remember this word, hyperbolic. PV, hyperbolic. The graph is probably for an isothermal process. Now, there are 3 graphs drawn at 3 different temperatures, and they can ask you which is the higher temperature. So it is very easy to find out. P into V is a constant. P into V is nRT. So wherever the product of P and V is higher, the graph would be that one. In this case, T3 is the higher temperature, T2 is in between, and T1 is the lowest temperature. This graph that we have drawn is known as an isotherm. Why it is known as an isotherm? Because it is drawn at a constant temperature. So this graph is known as an isotherm. This graph that is drawn here is known as an isotherm. The area under this graph, because it is a PV graph, is going to definitely give us the work done. So there is whatever the area is, that will give us the work done under this process. And as you can see, if the gas is expanding, it is positive work. If the gas is contracting, it is negative work. No prizes for guessing that one. Okay, now one of the most important things in this PV graph is this angle theta, which basically gives us the slope of the graph. Tan of this angle theta gives us the slope of the graph, and that is very important that you understand that tan theta, the slope of this graph, tan theta, and you can easily prove it, will be always equal to minus P by V. At different instances, value of P is different, value of V is different, and therefore the slope of this graph is different at different points. The slope of this graph, M, will be given by this minus P by V. It can very easily be proved. We don't have to go into that detail because it's just not important. P into V is constant, we differentiate it and we get the values. Okay. The next thing that we must understand, I hope everyone is noting them down. All these things are potential questions. Whether you talk about JEE or you talk about NEET, these are potential questions that we are discussing. Anything from this can come as a question in your exam as an objective. Okay, I hope we have noted this down up till here. The next thing that we are going to note down is the specific heat for this process. Remember, for every process that we do, every process that is done on a gas, there is a specific heat capacity for that process. That is delta Q divided by M into delta T. That is the specific heat amount of heat required to raise the temperature by 1 degree Celsius or 1 Kelvin. We can calculate this C for every process. We know for two process, C is known as Cp and Cv, process as constant pressure and process as constant volume. But for other process also, we can calculate this C. For an isothermal process, as there is no change in temperature, this C is not defined. Some people may call it infinite, but it is not defined because you are not going to change the temperature. If temperature is not going to change, whatever amount of heat you give, it is not required. It cannot change the temperature, and hence the specific heat capacity becomes infinite. It is very, 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 very high. Remember this. Again, I keep on insisting that whatever we are doing are potential questions. This part that I'm going to tell you is basically point number 6 is basically for your chemistry part. It can also come for physics. That is known as the isothermal elasticity of this gas for this process. You don't have to understand this. Whatever is written, that's just a proof. What you have to understand that this isothermal elasticity for this process is P. I have seen question both in NEET and JEE on this. What is the isothermal elasticity, or for every process in gas, the elasticity is different. Isothermal elasticity is equal to the pressure. And this is the last heading, the at NTP, the isothermal elasticity of gas. I have seen a direct question from this point in one of the NEET papers. Okay, so that is why note this down. In JEE, they are going to ask you what is the elasticity For isothermal process, what is the elasticity? For adiabatic process, what is the elasticity for this process? What is the elasticity for this process? That is how it is calculated. So please remember this. The next thing that we are going to understand is the work done in this process, and how do you calculate this work done is by the integration. Work done is P dV ka integral from V1 to V2. You put P as nRT by V and you just integrate it. And that is how you end up with this formula. Now remember, there are many ways to write this formula. This is the normal way in which it is written. Mu means number of moles. nRT log to the base 10 V2 by V1, final volume by initial volume, or nRT log to the base of 10 P1 by P2. P1 is the initial pressure and P2 is the final pressure. I hope you know this. Now, in many cases, instead of using this nRT here, remember this nRT can also be written as P1 into V1, or it can also be written as P2 into V2. So you can remember a various combination of this formula. Instead of using nRT, they might give you initial pressure and final initial pressure and initial volume. So instead of nRT, you can use P1 V1. And then they will give you how much the volume has changed. So depending on how the question is given, you can write the formula according to this. When you integrate this, you will get it to the log of base E, but then when you convert it into log of base 10, 2.303 is multiplied. You must know this. If you don't know this, you can note it down here. Everyone knows the work done in isothermal process, yes or no? Know it? Then the last process, then the last thing that you must understand at the end of it, at the end of whatever you do, the last process, the last thing that you must understand is we are going to apply the first law of thermodynamics for any process, because they might ask you not only the work done, they might ask you the heat given in this process, they might ask you the change in internal energy in this process. You must remember that since the change in temperature is zero in this process, there is no change in internal energy. There is no change in internal energy. So this amount of work which we have calculated here, that is also your heat supplied in this process. That is also equal to your heat supplied in this process, because whatever heat is given to this gas during this process, the entire heat is getting converted into work, which is not possible. It's only a theoretical process. It is not possible in actual. Total amount of heat cannot be converted into total amount of work. That is the second law of thermodynamics. Anyways, it is not possible, and therefore an ideal isothermal process is not possible in this universe. Have you noted it down, beta?
1 minute.
Let me know once you're done.
Done, sir.
Okay. Shall we move ahead?
Sir.
Remember, there are infinite number of questions that can be made in this topic, because for you can draw different graphs for the same process. There are infinite number of questions which are possible. I cannot do infinite questions. What I'm going to do is make a point, understand the point, and just move ahead, because the number of questions are infinite. So this is one question that I have chosen of the lot. Question number 1. PV की जगह is TV curve. TV curve of a cyclic process is given below. Find if the number of moles of the gas are n, find the total work done by the gas during the cycle. So I'll give you 2 minutes to think about it. Yes, beta. Anyone with any answer? Shall I do it?
Sir, answer 1.
Answer 1. 1. How did you get 1? I mean, you're not getting. How can you get 1? There is no dimension. 1 does not have any dimension. Work done should be having dimension of joules. How did you get 1 from? How did you get 1?
1 joule, sir.
1 joules. Okay, tell me, how did you get it, beta?
Area under curve.
Yes, beta.
Area under curve, sir.
Very good. Which curve is this?
TV curve.
Area under TV curve gives us?
T is proportional to pressure.
Wow. T is proportional to pressure. Okay, then. So if I draw a curve of temperature versus the volume, that is same as the curve of pressure versus volume. Is that so? That does not even stand as a logic. It does not even stand as a logic. The reason I am doing this thermodynamics is because I know that your thermodynamics is not so good, and I know that 4 or 5 questions are going to come from this topic, and that is why I keep on doing thermodynamics. That is not the case. Okay, let me help you out. I'll give you hint, and I hope that after that hint you can do this. What is this process from A to B? What is this process from A to B? I hope everyone can see this. If you want, I can show you a bigger picture. If you don't see it, I can show you a bigger picture.
Isochoric.
Okay, thank God. It's an isochoric process, so we can see this. Anyways, I will just put a bigger picture because one side, the only thing in the diagram is this picture, and after that you can just okay. The picture got too much big. The picture got too much big. Okay, so this is an isochoric process. This is an isochoric process. What is the work done in an isochoric process? What is the work done in an isochoric process, beta? Constant volume. Yes. No one knows it? Have you ever heard about an isochoric process? What happens in an isochoric process, beta? You can see it. What is happening here? Okay. So we have forgotten what is the work done. Abhiram knows it. Abhiram, well done. You are only the light of hope that I see in this complete darkness. Volume is constant in an isochoric process. So if volume is constant, then what is the work done in an isochoric process? Work done in an isochoric process, volume does not change. So what will be the work done, beta?
0.
Well done. The work done in this process is 0. What about this process? C to D. This question can come in NEET as well as JEE. It has got no special effects that it can come in a JEE Advanced. Okay, it can also come in JEE Advanced because it is just based on a concept. Yes. What about this process C to D? What is the work done in this process? What in this process is?
Isochoric.
No one?
0.
0. Take your time. I guess you are doing it for the first time. Don't worry. That's why we are in this class and doing something. So these two are isochoric process. Work done is 0. Well done. What about this process? What type of process is this? Isothermal. Well done. Now we are talking isothermal process, and I just now gave you the formula of work done in an isothermal process. Can someone tell me what is that formula for work done in this process, bacha? Huh? You've written the formula and we don't know it. Okay, I can write it as number of moles N, R, temperature here is 2T naught, NR into T, natural log of V2 by V1, final volume is 2V naught, initial volume is V naught. So my dear friends, this is the work done in this process, 2 N R T naught ln of 2. Do we understand this? Whenever there is an isothermal work, you will get a log, natural log or log to the base 10, depending on how you want to solve the question. I just did not want to write too much. So I cut out at 2.303 and therefore I get natural log. Do we understand this?
Sir.
And automatically, as you can see, it is coming as positive because this is expansion. Now, can I hope Can I hope that you can tell me the work done in this process? Can I hope that you can tell me the work done in this process? The only way you are going to solve any problem in a JEE or a NEET is when you do it yourself, not me telling you how to do it. Can you tell me what is the process? No, what is the work done in this process G2A? I hope you understand that this process is also what?
Isothermal.
Very good. Now can you tell me, bacha, what is the work done in this process? And then once you get the work done in all the four processes, you add them, you get your answers. Work done is a scalar quantity. Yes, bacha. Any hope? Should I hope against hope? Or should I lose hope?
minus nRT not L02.
Well done. So what is this? Okay, so the work done in this process is nR into the temperature is T naught, ln of final volume is V naught, initial volume is 2V naught. So it is ln of 1 by 2, and I hope you know the properties of ln. ln of 1 by 2 is minus ln of 2, ln 1 minus ln 2, ln 1 is 0. So you get the final answer as minus R nR T naught ln of 2. You know the work done in the first process, you know the work done in the second process. That is how, my dear friends, you will get the work done in this process, and the work done in this entire process will be equal to how much?
T naught Ln2.
nR T naught ln 2. That is how we do it. Do we understand this, or this has gone above what I'm saying? Ding, 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 ding.
Understood, sir.
Everyone understood this? Chalo. Comes the next one. Now again, I must tell you that the number of questions are infinite, and I cannot do infinite questions. I will just do some of these. Again, you cannot get the values because I can't tell you the values of ln. I don't know them, but can you tell me whatever you are getting? This is question number 2. How much energy is absorbed by a 10 kg molecule of an ideal gas? If it expands, forget about 10 kg, take it as number of moles. 10 moles. 10 moles of an ideal gas, if it expands from an initial pressure of 8 atmosphere to 4 atmosphere at a constant temperature of 27 degrees Celsius. And I hope for an answer here. Hoping against hope. Who is going to give me the answer? Who is going to be the light in the darkness all around us? Yes, 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 yes. Yes, 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 yes. Yes, 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 yes. No, no, no. Yes, yes, yes. No, no, no. Yes, yes, yes. Yes, 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 yes. Anyone? Huh? No one, sir. This is a question of JEE Main and NEET. It can never It can never come in a JEE Advanced. Anyone? Okay, shall I do it? It is given that the gas is expanding at constant temperature. So this must be an isothermal process. I realize it, I see it, and I just put the formula, work done in an isothermal process. But they are asking you how much energy. That means they're asking you about the heat. But you must understand that this delta Q is equal to delta W, because delta U is 0, because this is an isothermal process, my dear friends. That would be equal to N is 10. That will be equal to multiplied by R is R. Temperature, we cannot write the temperature in degrees Celsius. We have to write it in Kelvin. So it is 300 Kelvin. ln of P1 by P2, 8 by 4. So my dear friend, 3000 R ln of 2 is the answer that we are looking at. Do we understand this? Anyone having any doubt, please raise it. Raise your voice, raise your doubts. Huh? Do we understand this, or this is gone above and saying bye bye?
Understood, sir.
Bye bye sir, bye bye. हो गया, निकल गया. Chalo. Come on, buck up, buck up, buck up. Take a deep breath. Relax and solve the next question. Again, you might not get the answer in the pure form, but even the unpure form will do. This is more likely a question of chemistry rather than a question of physics, because volume is given in liters and this and that and then. Doesn't matter. Physics or chemistry, all are brothers and sisters. India is my country. All Indians are my brothers and sisters. I love my country. Blah, blah, blah. And I'm proud of its rich heritage and culture. Yes, I am. Anyone with this one? Or shall I give up? Give up, give up, give up, give up. 1 mole of O2 gas having a volume of this, and 1 atmospheric pressure is compressed isothermally so that its volume reduces. Everything is given. Any hope? No hope. Hope is there, sir. Yes.
273 R ln 2.
273 R ln 2. That is correct. Work done is N is 1 into R into temperature. Temperature is 0 degrees Celsius. That is 273 K. ln of reduces. So it has to be negative, my dear friends. Minus, or I should say plus, ln of final volume is 11 by 2. Initial volume is 22 by 4. So you will get it as ln of 1 by 2, which is minus of ln 2. So the final answer will be minus 273 R ln of 2. That is the answer that we are looking at. Everyone understood this, or this has gone above? I think bye bye, sir. I'm going.
Understood, sir.
Okay. This is again a knowledge-based question, likely to come in all the 3 exams, because you know it, you know it, you don't know it, you don't know it. As simple as that. This is the one. An ideal gas A and a real gas B have their volume increased from V to 2V under isothermal conditions. So in a JEE main or JEE or NEET, if it comes, it will come in this form. In JEE advanced, when it comes, probably they might give you a graph between real and ideal gases, or they might ask you which is the graph of real gas and which is the graph for ideal gas in an isothermal process, my dear friends. And ideal gas A and a real gas B has their volume increased from V to 2V under isothermal condition. The increase in internal energy. Increase in
Zero,
internal
sir.
will be same in both A and B, will be zero in both cases. Of B will be more than that of A, of A will be more than that of B. A, B, C, D, and what is the answer, my dear friends? Question number 4 on isothermal process. We are dealing with isothermal processes.
Option B, sir.
Will be zero in both the cases. Remember, this is an ideal gas. Change in internal energy has to be zero. An ideal gas. Here it is not equal to zero, my dear friends, because this is not an ideal gas. This is not an ideal gas, my dear friend. This is not an ideal gas. This is not an ideal gas, my dear friend, because this intermolecular attraction, and because of that, you have to do more work. And therefore, this is the answer. C. Note this down, keep it in a safe somewhere. You might be able to extract it when it is needed. Remember, all these questions are real gems, and I'm more like a jury here who is trying to pick out the gems and put in front of you. And you are my prospective customers. All these questions are real gems, trust me. Because they are equally likely to come in any of the 3 exams. This may come in main or JEE advanced. Have you noted that question down? Yes or no? No, yes. Huh?
No, sir.
No, sir. What are you doing, sir? Sleeping, sir. Today is Sunday, sir. We are sleeping, sir. Sunday is a rest day. We rest on Sundays. No, Sunday is not the rest day. In fact, Sunday is the day where you must work the most. Yes, are we done? Nah? Ding, 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 ding. Ding, 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 ding.
Done, sir.
Then, sir, this question, sir. Since we talked about real gas, so here comes a question on the real gas. And if you apply some common sense, you should tell me which will be the correct option. Work done by a system under isothermal change from V1 to V2 for a gas, which is a real gas, which obeys van der Waals equation. This van der Waals equation is not a part of physics, but is a part of chemistry. But a question has come based on these real and ideal gases, and they are more likely to come in JEE advanced. And then this question is more likely to come in your chemistry if it does not come in JEE advanced. You don't need rocket science to understand this. This is thermodynamics. This is part of rocket dynamics. So when the rocket goes up, gases come down. Thermodynamics is a part of rocket mechanics, rocket science. Yes. Work done by a gas, by a real gas in isothermal expansion. And the answer is my dear friends, the answer is okay. Let's not waste any time onto this. This is the answer. Remember it, the work done is more. So remember the answer. Option A. Option A, my dear friend. Sweet option A. Option A, option A, option A. Shall we move ahead in life?
Sir.
Huh? Done, sir. Well done, sir. This is the next question. And I did this question last year also with the students of JEE of the last year. Online, of course. So this is the question that I did. Question number 7. 1 kg of water at 373 Kelvin is converted into steam at same temperature. Obviously, temperature cannot change. Volume of 1 centimeter cube of water becomes 1671 centimeter cube on boiling. What is the change in internal energy of the system? The latent heat of evaporation of water is 5.4 into 10 to the power 5 calorie per kg. This is the question that we did. This is the question that we did, and this is the question that came in JEE Advance of the last year. So you can match. And match word to word. Apart from the usual heroics, the question is same. You match this one with this one. You can also match this one because we have already done this. You can also match the third one because third one we have also done. So I'll show you the entire paper, the 4 questions that came as match the following in JEE Advance of last year. And I understand that, I hope that I have given you enough arms and ammunition to tackle all these 3 questions in less than a minute. So you can do this entire 4 questions in less than a minute, I think so. Anyways, that's not the point here. The point here is to do this one. And how are you going to do this one? So concentrate on this one. This is not likely to come in NEET. Very unlikely. But anyone can do it. That's not the point. I hope I made the point clear. So if you pay enough attention in the class, well, you might be there. You might be surprised at the question paper because you might find the same question in the question paper. So have faith. That is the reason we are doing this class. Coming back to the question. Okay. The clean sheet. Roy is gone. Anyone? Anything that looks like an answer? Pressure is not given here, so you have to take it as atmospheric pressure. Pressure is not given here. Pressure should be taken as atmospheric pressure. So you can take it as 1 into 10 raised to the power 5 pascals. I think they missed giving you the pressure. Again, this question is tougher than the question in the JEE because the units are here and there. How are you going to do this? Probably doing the question of JEE is rather simple, but this is more tough compared to the unit. So what we'll do is we'll solve the question of JEE rather than solve this one. This will just give you nightmares in calculation. So let us solve the question of JEE. That is simpler. Remember, any question that will come in a JEE is a simple one. That's why it has come. How will you do it? Yes. Huh? No idea, sir. How do I have an idea, sir? Get the idea, sir. Yes, my dear friends. Have faith. Your faith should remain intact. Whatever happens. How will you do it? Okay. So how are you supposed to do this? We are doing this first law of thermodynamics. It is also applicable here. I must have told you. I must have shown you this question before also.
The previous question also we can apply first law of thermodynamics.
Every question is like that, beta. JEE is very simple. If you just apply your common sense, delta Q is delta U plus delta W. What you need to find out? Internal energy ka change we have to find out. Do you understand why I'm paying so much attention on this question? Because I know that they are going to come. So basically you have to find out delta U. Delta U will be delta Q minus delta W. Now, how much is delta Q? It is M into L. Do we remember this?
Sir.
Mass into latent heat of vaporization. That is delta Q. Yes or no? No, yes.
Yes, sir.
Minus work done. Now remember, this process is taking place at a constant pressure also. Yes or no? And that is why the volume is changing. Do we understand this? So work done is pressure multiplied by change in volume, bacha. That is how you have to do it. Pressure is 10 raised to the power 5. Change in volume, final volume is 10 raised to the power minus 3 minus initial volume is 10 raised to the power minus 6. Just have to calculate this. You get your answer and you stay happy. And I think the answer that you are getting is somewhere around 2 kilojoule. That is the answer. See? Do we understand this or this is going above our head saying bye bye, bye bye, bye bye? Huh?
Yes, sir. You can also solve the second question. It's an isobaric expansion. What you got to do? Delta Q is NCP delta T. That's it. N is given. CP, diatomic gas is given. No, sorry, you have to find out delta U. Sorry. Delta U is NCV delta T. This is JEE advanced. N is known. CV is 5/2R delta T. Anyone can find out delta T, yeah. Change in temperature. Initial temperature is given. Initial volume is V. Now the volume is 3V. Isobaric. P is constant. So volume is directly proportional to temperature. Volume becomes 3 times. So temperature becomes 3 times. Yes or no? So initial temperature is 500. Final temperature is 1500. Change in temperature you will know and you will get the answer straight away. So that is this one. You cannot do question number 3 because you have not done adiabatic process. Question number 4 is as simple as this. 3 moles of an ideal diatomatic whose molecules can vibrate. So this is vibration coming here. Vibration, 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 vibration coming here. Given you so much on vibration. Yes or no? So if it vibrates on one axis, the degrees of freedom will become how much?
7.
7. So Cp will become 9. That's it. Cp by Cv nikalna hai. We have done the same question. 9 kilojoules of heat is given. Find the change in internal energy. You have to find the ratio of delta U by delta Q. We have seen so many questions here. Ding 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 ding. You can go back and just see that we have done the same question here. This is the same question, beta. This is the same question. You have to find out whatever ratio. Same question. This is the same question. All these are same question. The only change in the question that came in JEE was that they had given the vibration. So for 1 degree of vibration, you would have 2 degrees. See this one. This is exactly the same question that came in JEE. Exactly the same question. The only thing is they have changed the degrees of freedom, nothing else. Moral of the story is do what is done in the class and you are good enough to solve any question that comes in any exam. Anyways, I will rest my point here and move on to the next process. And what is the next process known as? We might have to come back to that JEE wala question because the next process is coming. What is the next process known as? Huh? Isobaric?
Isochoric.
Adiabatic. Adiabatic process. Adiabatic process. Normally I do first isochoric, then isobaric, then isothermal, then adiabatic. This year I've changed it because we have done isochoric and isobaric. We have done something of isochoric and isobaric. So I thought that we'll do first isothermal and then adiabatic. Yes. What is special in this process? Delta Q is 0.
Delta Q is 0.
And that process change in temperature was 0. Here delta Q is 0. Here all the 3 things change. Pressure, volume and temperature changes. Of the gas. Do we understand it or this is going about saying bye bye? Bye bye sir, bye bye. So this is a process where all the 3 quantities are going to change, my dear friend. And what is the what do you want to have an ideal ideal adiabatic process? For an ideal as an adiabatic process, what should be the condition? Yes,
All of container is perfectly insulating.
perfectly insulating. Why you want it to be perfectly insulating? Why? Because the only condition which is required for any process to be adiabatic so that there is no exchange of heat is that there should not be any heat coming in, there should not be any heat going out. So if you don't want any heat to come in or go out, the process must take place in a perfectly insulating environment. And therefore, whenever you hear the term, the process is taking place in an insulated cylinder, 99.9999% that process would be adiabatic in nature. So the only condition we have to understand is, since there is no heat exchange required, you don't want any heat to get exchanged, the process must take place in perfectly insulating wall, as well as the piston has to be perfectly insulating. Then the second condition was it must be very fast. Hui, hui. Why it must be very fast? So that there is no time available for heat exchange to take place. It will take some time for heat to go out or come in. The process takes place very fast. Very fast. There is no time for heat to exchange, and then the process would be ideal adiabatic. Remember, no process in the universe can be an ideal adiabatic or an ideal isothermal, because ideal process only exists in theories. Similar to human beings, an ideal human being only exists in theory, and they do not exist for real. But then there's a definition of an ideal human being. We can be as close to an ideal human being as possible. That must be our endeavor. What are the examples of this adiabatic process? So anywhere you hear all these things, these are examples of perfect ideal adiabatic process. Sudden expansion of gas, non-conducting walls, sudden bursting of tube of cycle tire. So if there is a question where the cycle tire bursts, that's an adiabatic process. Propagation of sound waves in air. Propagation of sound waves in air. Expansion of steam in a cylinder of steam engine. These are your expansion, which are adiabatic in nature. Do we understand this, or this has gone above? I saying bye bye, sir, bye bye. I'm going bye bye. Huh?
Understood, sir.
Shall you move on in life? Life has to move on.
1 minute.
Okay, 1 minute. You can cook a Maggie in 2 minutes. I can give you 1 minute. Yes, have you noted it down, bacha?
Yes, sir.
Shall you move ahead in life? So now comes the equation of state for this. How do you write the equation of state? Remember, here nothing is constant. P, V, and T all are changing. So you can write P, V by T is equal to constant. This is first way of writing it. Many times we forget it. That is why we write it. P1 V1 by T1 will be equal to P2 V2 by T2. and that will be equal to N into R, where N is the number of moles. Number of moles is still going to remain constant because gas is not going to escape unless and until we make a question where it does. Okay. The other way of writing this is a very democratic way, PV raised to the power gamma, where gamma is known as the adiabatic constant. We all are aware of this equation, yes or no? Eh?
Sir.
Okay. The other way of writing this, and you must remember all these three ways without any excuse. TV raised to the power gamma is constant, which is not my favorite, but see, it's not about playing favoritism here. You must be able to remember all these 3 or 4 variations of the same equation. Then this one is definitely not one of my favorites. I can't remember it ever, but you will have to remember it. You will have to remember it. There is no escaping this one. You'll have to remember it. Remember it. There are no excuses for not remembering it.
Done, sir.
Anyone, sir?
Done, sir.
The next thing that comes is the indicator diagram. So write the heading indicator diagram of this gentleman. And the indicator diagram of the gentleman looks like this. It looks of the similar nature as your isothermal process, but the slope is not same. The tan of this phi is, and remember this, minus gamma times P by V. So slope of this graph is gamma times more than the isothermal graph. Please remember this, my dear friends. Slope is gamma times. Have we noted it down, bacha? Yes or no? No, yes.
Sure.
Shall we move on in life?
Yes, sir.
Then the next thing is specific heat for an adiabatic process. You must understand that there is no heat exchange, so it is 0 divided by something, and therefore specific heat capacity or specific heat for this process has to be 0. Have you noted it down?
Done, sir.
Then, as I said, for every process, we also have elasticity. Adiabatic elasticity is gamma times P. Isothermal elasticity was P, so this is a very, very important relation that could come in your physics as well as your chemistry. Adiabatic elasticity by isothermal elasticity for any gas should be equal to gamma, the ratio of specific heats of the gas. Remember this, keep it in safe deposit somewhere where you can extract it. Have we noted it down, my dear friends? Yes or no? No, yes. Huh?
No, sir.
Okay, sir. You don't have to write down the entire Ramayana. No one is asking you to recite the entire Ramayana. They are only asking you who is Ram and who is Sitaji. So you must know Ram is adiabatic process and Sitaji is isothermal process. And Ramji is gamma times P and Sitaji is P. That's all we need to know. Not the entire
Done, sir.
Ramayana. Okay?
Done, sir.
If something is on the board, you don't have to note down. We. Take a deep breath. See what is written. Understand it and write it in your own language. Tulsidas ji wrote his own Ramayana and that's why he became Tulsidas. Did not copy it from someone else. So you write your own Ramayanas and not copy it from the Ramayana on the board. Okay. The next one is work done in this process and no prizes for guessing this. Who is going to tell me the work done in this process? Eh? Tell me. Carry it on.
Minus delta U.
Yes, work done is actually equal to minus delta U. But what is minus delta U? You can write it as N R into delta T upon 1 minus gamma, or you can write it as P2 V2 minus
CP dt.
1 upon 1 minus gamma. What you're going to say is we are going to do it in the next heading. We are going to apply FLTD on this process. Once you apply FLTD on this process, it becomes quite evident that delta Q is equal to delta U plus delta W, and this process delta Q is 0, so your delta W becomes equal to minus of delta U. It becomes minus of delta U. So now you can write delta U in different form. Minus N CV delta T, that is the first form. CV can be written as minus N R upon gamma minus 1 into delta T. You can also write it as P2 V2 minus P1 V1 divided by 1 minus gamma. So this is the way I remember work done in an adiabatic process. If you want, you can remember it in the same way.
Done, sir.
Everyone has done it, sir?
Sir.
Then this is a comparison between adiabatic and isothermal process. This question has come various forms, various types in various exams. So if you are given two graphs for an isothermal and an adiabatic process, this is compression process. Which graph will be of adiabatic process and which graph will be of isothermal process? Tell me, graph number 1 and graph number 2. Which graph is adiabatic and which graph is isothermal? Remember the slope of adiabatic graph. Remember the slope of adiabatic graph. Remember the slope of adiabatic graph.
2 adiabatics.
Shabash. The slope of adiabatic graph is greater than the slope of isothermal graph. The slope of adiabatic graph is more than the slope of isothermal graph. And someone said that 2 Number 2 is the adiabatic graph. Number 1 is the adiabatic graph. It is steeper. And number 2 is the isothermal graph. Please remember it. Don't forget it. The slope of adiabatic graph is always more than the slope of the isothermal graph. Please remember it. Do we understand this? Yes or no? This is one about it saying bye-bye. Bye-bye, sir. Do you understand this, sir?
Understood,
Yes,
sir.
sir.
Thank God, sir. Please remember it, sir. Do not make the mistake, sir, because this question may come in the exam, sir. And then we cannot look here and there, sir. Oh, I don't know this. You must say, no, 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 no. I know this, sir. I will give you the answer, sir. Wait, sir. Wait, sir. Wait, sir. Answer is coming, sir. Have you noted it down? Yes or no? No, yes.
Yes, sir.
Then this is the expansion process. Now, which graph is adiabatic and which graph is isothermal? Remember, the slope of the adiabatic graph is more than the isothermal graph.
Second one adiabatics.
Yes, now we understand. The second one is adiabatic. And the first one is isothermal. Do we understand this, or this is gone about it saying bye bye? Remember, nothing should go above our head because this is the simplest topic, one of the simplest topic in physics. If things start to go off our head, this is one of the most scoring topics in physics. Any question in thermodynamics, if you cannot do, that means you have lost 5 marks. Whether it is in for chemistry, this might be the tougher topic, but for physics, this is the easiest one. You must remember that, my dear friends. Okay. Shall we move ahead? Huh?
Sure.
Everyone has noted this down.
Yes, sir.
Comes the next question, my favorite one. This has come in many exams many times. I'm drawing it for you. Shall we move ahead? These are the 3 graphs drawn for 3 gases for adiabatic process. One gas is monatomic, one is diatomic, and one is non-linear triatomic. Which graph is for which gas? Which graph is for which gas? Number 1, number 2, number 3. Which graph is for which gas? One gas is monoatomic, one is diatomic, the other one is polyatomic. Yes. Huh? No one? How will you find out? I'll give you 2 minutes to show me your talents. Is there any hope or shall I do it?
The first one polyatomic, sir.
The first one polyatomic, okay. Second one,
Diatomic.
well done. Third one,
Monatomic.
well done. Why did you say so? Why not the reverse? What makes you think that this is poly, this is dia, and I mean number 2 is going to be dia, whatever happens. The only confusion is in 1 and 3. Why did you not say the reverse one? Number 1 is polyatomic, yes or no? Or number 1 is monatomic? Huh? Okay.
Sir,
Yes.
man pi equals to minus gamma p by v.
Yeah. So, what is the gamma for a monatomic?
Pi by 3, sir.
Diatomic?
7 by 5.
Polyatomic?
4 by 3.
Which has got the most gamma? The greater gamma. Whose gamma?
No,
is-
sir.
Huh?
Monatomic.
So whose slope is more? So number 1, hero number 1 is monatomic, more slope, more steep, more gamma. मैं तेरा hero number 2 is diatomic, and the third hero is polyatomic. You understand this? David Dhawan movie, hero number 1 or coolie number 1, whatever it was. We remember this, not that movie, this concept. Movie you may remember, you may not remember. Doesn't matter. Remember this concept, yes or no? Huh?
Yes, sir.
पक्का ना सर?
Paka, sir.
कच्चा पक्का पक्का पक्का. Note this down. Noted it down, everyone, sir?
Noted, sir.
Okay, sir. All these are potential questions that are going to land up in your exams. Trust me on this. That's why I'm paying so much attention on this. Well, I know this is going to come, and for NEET, 4 or 5 questions we are solving. 4 or 5 questions make a hell lot of a difference. Now again, the same question comes, but now it is adiabatic compression. Again, there are 3 gases for which adiabatic compression is shown, and now I will rely on my warriors to tell me which one is which gas, and you have 2 minutes to show your talents. Who is hero number 1? Who is hero number 2? Who is hero number 3? Video number 1, Varun Dhawan. Video number 2, Siddharth Malhotra. And that was Student of the Year, first part.
One monoatomic, sir.
And monoatomic, sir. That is correct, sir. That's why I drew it in the same color, sir, so that at least color will make you understand that this is monatomic. But JEE, NTA people and JEE advanced people will not be so kind that they tell you they draw it in different colors. They will not be so kind. Remember, the steeper one is the one which has the most slope. And in this case, monoatomic is the steepest, my dear friend. We understand this. Yes or no? No or yes? We understand this, everyone, or this has gone above our head saying bye bye, sir. बहुत हो गया sir अब.
Understood, sir.
पक्का sir?
Pakka, sir.
ठीक है. So remember these two small things because they have come in various exams in various ways, multiple times. I can't even count how many times this question has come. Okay. Now let us so that is how we start our journey in adiabatic process, and this is the first one coming for you to warm you up to the questions that are coming, and this is the first one. This is from previous year JEEs. The question is right there on your screen. Question number 1. During an adiabatic process, the pressure of the gas is found to be proportional to the cube of its absolute temperature. The ratio of Cp by Cv of the gas is. This is an adiabatic process happening. Yes, any hope? Yes, sir, hope is there, sir. No, sir, hope is not there, sir. Do I see any hope anywhere in anyone's eyes? No hope.
Option C, sir.
Option C, sir, that is an hopeless option because hope does not come from that option. That is wrong option, sir.
Option A, sir.
Option A, sir, that is also correct. That is correct, in fact. I was saying that was wrong, but that is correct. 3/2 is the answer. How did you get it? Akkar bakkar bambe bo? 80 90 pure 100? Yes or no? How did you get it? Now remember, I told you that there is no way that you should forget these three processes. Because in the examination hall, in the heat of the examination hall, we are studying heat, and in the examination hall also you are going to feel a lot of heat. You must remember these three. Or if you remember any one from getting the equation that you require from that first equation may also be a task, because you may make a mistake, and if you make a mistake, then then things may not turn up. Now, this is the way you must remember this equation. There is another way that you can remember this equation. And again, I don't want you to confuse with a lot of variation, but see, the more the number of ways that you can remember, in some questions you can get the answer quickly. PV raised to the power gamma is constant, so you can remember this also in this way. P is inversely proportional to V raised to the power gamma. TV raised to the power gamma minus 1 is constant, so I can write T is proportional to V raised to the power 1 minus gamma. Different ways in which you can remember the same equation. T raised to the power gamma 1, P raised to the power 1 minus gamma, you can also write it as P is proportional to T raised to the power gamma upon gamma minus 1. Now, what's the benefit of remembering this form? Because in an exam, any one of this form can just fit instantly and you can get the answer straight away. For example, in this particular question, this form fits straight away. This form fits straight away. Because I know that I hope you're understanding what I'm going to say. In the question, before the question also, I know that pressure is proportional to temperature raised to the power gamma divided by gamma minus 1. Here it is given as pressure is proportional to T cube. So you now know that gamma upon gamma minus 1 is equal to 3. Straight away you get the answer of gamma. Your gamma becomes 3 by 2. Now this is how you can do the question faster. Obviously, if you don't remember it, if you just remember any one of this, you can derive the relation, not a problem. You can derive the relation and you can do it. If you can remember them, well, that 5, 10 or 15 or 20 or 1 minute that you are saving is going to make a lot of difference at the end of the exam. At the end of the exam, where you get your results. JEE is all about JEE and NEET. NEET is always about 100% speed. JEE Main is about 99.9% speed. JEE Advanced is about 80% speed. You can do it quicker. You can do a lot of questions more comfortably and more easily. Do we understand this? Yes or no? The benefit of remembering the processes in different forms. Can you move on to the next one?
Understood, sir.
Comes the next one, question number 2. An ideal gas is, this question can come in JEE Main as well as NEET. Advanced, there might be something that they will ask something else, not this exact maybe. An ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of its original volume. Gamma is 5 by 3. So this is, I think, a monatomic gas. And the rise in temperature is, and your time, my dear friends, starts now. Yes, my dear friends. Is there any answer anywhere? You have 2 minutes to show your talents. Yes, my dear friends, boys and girls. No one with any answer? Is thermodynamics was done in chemistry also, no? Isn't it? Was it done in chemistry? No.
No, sir, not done yet.
In physics? Previously? Previous class? Not done?
In the beginning.
Okay. कोई बात नहीं. Now you are able to understand this? Yes or no?
Yes, sir.
Okay, how will you do this? It's a simple question, beta. Try it, try it. These are the type of questions that are going to come in the exam. They are very simple one. I showed you the questions from JEE as well. That JEE Advanced, not JEE Main. JEE Advanced, I've showed you the question. Questions are pretty damn simple. And these are scoring topics, beta. We can't let the question of this topic go away. So that would be disaster. We can't let disasters happen. I'll give you time, don't worry. There's nothing in this question that you can't do. There's nothing in this question that I'm going to tell you.
Sir.
Yes, I have an answer. Yes. Which one?
B.
405 calories. 405 kelvins.
Option B, sir.
Option B, sir, is the correct answer, sir. It is 375 Kelvin, and that is absolutely correct. How are you supposed to do this again? Here, the temperature and volume is given, so you must apply the relation of temperature with volume, which is not one of my. I just can't remember it, but I'll try to remember it. Can anyone tell me what is the ratio between temperature and volume for an adiabatic process?
PV power gamma minus.
TV raised to the power gamma minus 1. Why I am doing all these questions, beta? Because I want you to by heart this formula. The more you will use this formula, the more you are likely to retain them in your head. So basically, I can write from here T1 by T2 will be equal to V1 by V2 raised to the power of gamma minus 1 or 1 minus gamma. Now, if you just make a mistake here, you are done.
-1, sir.
Huh?
Gamma -1.
That is a mistake. I've taken the direct ratio. That is a mistake. And that is why I did it. If I take it as V2 by V1, then it is gamma minus 1. And these are the simple things that you will commit a mistake in the examination hall. And that is why it is essential that you do these questions here right now. Remember, JEE is clear in the classroom, not in the examination hall. So if you've done this mistake, well, your entire answer will go doi. It will not come correct. So I hope you have understood this. Yes or no? So I can put the value and I can get the value of T2. So I think your final temperature T2 will come as initial temperature T1 into V1 by V2 raised to the power of gamma minus 1. Am I correct?
Sure.
T1 is 300 Kelvin, V1 by V2 is adiabatically compressed. Again, there is a twist here. Adiabatically compressed to 8 by 27 of its initial volume. So V1 by V2 becomes 27 by 8. Do we understand this? So these are the small things. The only reason I am giving you this question is because you have to understand these ratios and when it is inward and when it is Sida. Now when you put the value, you will get the answer as 675 Kelvin, but they wanted you to ask to find out the change in temperature. So it is 675 minus 300 and you land up with 375. Do we understand this, how it is done, and what are the things that you must remember while solving such questions? Yes or no? No, yes.
sir.
Simple things in taking the correct ratio, dividing it correctly, multiplying it correctly, and be careful because you are bound to make mistakes. You are bound to make mistakes. Anyone can make a mistake. I definitely would have made a mistake because I'm not very sure about these ratios. The ratios confuse me. I always do the ulta. But I can get away with it. You can't. Well, if you do ulta, you will get -5. So don't do ulta, only do see that stuff. Let's see this one. Question number 2 in this category, gamma is 2.5, the volume is equal to 1/8 times of the initial volume, then pressure P dash is equal to how much? Times the original pressure.
C, sir.
Okay, I have an answer here, sir. See, sir. Let me check it with the answer sheet that I have. It is C, sir. Congratulations. You have got the correct answer. C, sir. That is correct. Anyone understands this? Yes or no? Just have to apply one of the formulas that we have done.
PV gamma.
Power gamma is equal to constant. So if you are scared of writing the ratio, so what I do, I write it this way: P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma, so that I do not do a stupid mistake. So from here I can write P2 as P1 into V1 by V2 raised to the power of gamma. So I can get P2 as P1, V1 by V2 is 8. So 8 raised to the power of 5 by 2. Yes or no? Everyone understands this? And 8 is 2 raised to the power 3. So I get P into 2 raised to the power of 15 by 2. Everyone got this? Yes or no? Everyone understands how this is done?
Sir.
Now, this is one of the current questions, and this is how the current questions are framed. They give you some ratio and they give you the value as well. So let us do this one. A gas has a pressure P and volume V is now adiabatically compressed to 1/34th of its original volume. If this is equal to this, the final pressure is. The gamma of this gas is not given, so you can take gamma as 1.4.
Option B, sir.
Option B, sir, that is correct, sir. Everyone got the answer? Yes or no? Great, Abhiram. Well done. So again, you have to apply the same concept. P1 V1 raised to the power gamma is P2 V2 raised to the power gamma. And once you do it correctly, you must end up with the correct result. Okay, well done. Shall we move ahead? Next one is this one. And these are the type of questions that confuse students a lot. Let's see if you get confused or not. Two samples A and B of a gas initially at the same pressure and temperature are compressed, the same volume also, from V to V by 2. A is done isothermally, B is done adiabatically. The final pressure of the gas A is dhan 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 dhan. See, sometimes they give you graph and sometimes they don't give you graph and then ask you this. You will have to, these are the questions that sometimes confuse us. And these are the type of questions that are coming in exam these days. Apart from the question on cycles, we'll be doing them as well in the next class. Next class will be the class where we'll be winding off this thermodynamic process once and for all. Well, if you can't understand from the graph, you can also do it for an isothermal process. For an isothermal process, my dear friends, P1 V1 is equal to P2 V2. So I can write, yes, beta.
Option C.
Option C is correct. See, now we are getting the hang of this process. P1 V1 is equal to P2 V2 for an isothermal process. So I can write P2 as P1, which is P into V1 by V2. The final volume is V by 2, so it becomes 2 times P. Yes or no? Volume becomes half, so pressure becomes 2 times P. As simple as that. Now, if I talk about an isothermal process, it is P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma. From this, I will get P2 as P1, which is P into 2 raised to the power of gamma. And this gamma is greater than 1. So your final pressure of B would be more than the final pressure of A, or the final pressure of A would be less, and therefore C is the correct option. Do we understand this?
Yes, sir.
Now this is one which we have already done, and I told you has come in exam multiple choice in different ways. So can you give me the answer for this one quickly? 4 curves A, B, C, D are drawn in the adjoining figure for a given amount of gas. The curve which represents the adiabatic and isothermal changes. Any one of these questions will land up in your paper. That's my bacha. Anyone with anything that looks like an answer? Sounds like one, feels like one. See, so much of confusion. And the answer is? No one knows the answer. The answer is See. Remember, these curves are not possible here when pressure is increasing, volume is increasing. They cannot be isothermal or adiabatic because these two curves have positive slopes. Both the isothermal and adiabatic has negative slope. When pressure increases, volume decreases. When pressure decreases, volume increases. Do we understand this? So these C and D are out of the question. Only thing that is left is B and A. Out of which B and A, which one has got more slope? A has got more slope. So A should represent the adiabatic process and B should represent the isothermal process. Do we understand this?
Sir.
How many of you got the answer for this question but could not speak? No one got the answer to this question. So no chance of speaking.
Sir, we got.
Okay, well done. Then, as I told you, this question has come many times in many exams in many different ways. The first time I think it came was in the year of 2010 with this question. PV graph for two questions. Two gases during an adiabatic process given. Clause 1 and 2 should correspond to dung 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 dung. Yes. Char dung 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 dung. Anyone can give the answer for the dung 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 dung. Huh? Plot 1 is for which gas? Plot 2 is for which gas? And the answer is
A.
And the answer is B, my dear friends. How many times we have done this question, still we don't understand. This has to be my diatomic gas, my dear friends. Less slope, less gamma. More slope, more gamma. Mono, more, mono, more. Monoatomic gas has more slope, more steep. This is helium, my dear friends. Do we understand this or still going above our head saying bye-bye? Sir, nikal gaya ab to.
Yes, sir.
A simple mistake lands you up in trouble, my dear friends. See, I've told you. Chalo, this one though, there are two simple questions. Answer them quickly so that we can move ahead with this class and we are done with this class. This one comes, so looks like a very simple one. Do we have an answer? See, simple question, land up in trouble. Yes, my dear friends. In an adiabatic expansion of a gas, dung, char dung, which is the correct dung. Huh? How many things we'll remember, sir? Yes. Is there any answer coming from anywhere? From left, right, front, back, above, below? And the correct answer is temperature falls. Why does the temperature fall? When we were discussing this first law of thermodynamics, someone told me, sir, delta W is minus of delta U. Someone told me that. In expansion, work done is positive. So this has to be negative. If change in internal energy is negative, then the temperature has to fall. Simple logic. So, the moral of the story is, remember, simple things. Do we understand this? So, as a matter of fact, we have come and end to this class. We will continue this discussion. Two or three more processes are left. We will dissect them one by one, and then we will go on to those questions where every process will come together. Right now, they are coming separately. They are not united. They are divided, and they are still fighting. And they are winning the battle, it seems, because we are not able to solve the questions. See what will happen when they come together. So we have to be careful that when they come together, we'll have to identify which one is which and then tackle the enemy accordingly. So we'll see that in the next class. Take care. God bless all of you. Bye-bye.
Bye, sir.
Hi, sir.
If anyone has any doubts, you can ask them.